Good afternoon, everyone. I'm Trevor Mack. I'm a senior principal architect at Atlassian, and my colleague Arun will come up in a second. Today, we're going to be talking about how we built customer-managed keys in our product, or as we call it, customer-controlled encryption, using AWS KMS. So we're going to be talking about encryption today. Our overall agenda, I'll start with some encryption foundations, talk about some primitives here. I'll then advance into discussing a little bit about our platform. We call it Cryptor internally. There's also a blog on our engineering blog. We published about how we built Cryptor and what it does for us, and I'll be talking about that today. And then we'll transition to thinking first about what the customer is wanting in this particular solution that we've built. Talking about a little bit about key models. So there's different ways that encryption keys can be modeled and managed in a multi-party system. And then we'll get into two of the offerings that we've built, bring your own key, and then a customer managed key solution that builds on top of that. And then finish up real fast with just a couple lessons learned that we've had over the years. So to start, most of our encryption is using envelope level encryption. If you're familiar with AWS KMS, you've heard of envelope encryption. There's a couple different keys. One of my favorite topics that my colleagues always mention is whenever we talk about a key, I always ask the question, which key are you talking about? Because there's a lot of them. And so here I want to define a few. A data encryption key is actually encrypting the actual data. A key encryption key, or usually referred to as a KEK or KEK, also wrapping key, lots of different terminology, is encrypting that data key. So that's actually protecting the data key, not the data underneath it. And then those two combined ultimately make an EDEC or an encrypted data key. And that's going to be stored alongside your data. When we talk about encryption, there's also three different layers that I want to get into, one of which is volume or infrastructure layer. This is where you're encrypting an entire volume of data with a data key that we talked about earlier. So that entire volume is encrypted with one key. That's the granularity we're talking about. A second one that we've termed internally is called application layer encryption. Some of you might know it as client-side encryption. We've defined this a little bit differently, and I'll talk about why. So here we have a compute that's hosted in three different hosting environments, a Lambda, an EC2, and EKS, so a container system. Envelope encryption is that middle box here, where we're combining a document, some plain text, with a data key, and encrypting that with a KMS master key, or referred to as a KMS key. That turns into your encrypted data. So that has your encrypted data key that I earlier talked about, and that has the ciphertext of what that data represents. And then we're going to store that in some system. Here, I've specified three DynamoDB, an S3 object, as well as an SQS queue event. That's where your encrypted data is going to be hosted. And of course, you're going to have volume level encryption on your S3 bucket. You're going to have volume level encryption on your DynamoDB table. But here, we're doing application level encryption. So we're encrypting data that's being sent to those systems. Why is that different than client-side encryption? That's a great question. Thank you for asking. Client-side encryption for us is referring to the client device that's on the customer's network. That could be a laptop on a web page. That could be your mobile device. And that is doing, very similarly, client-side encryption. Again, we have a deck. We have a document. That turns into encrypted data. And that encrypted data then gets sent to our servers. That is what we refer to as client-side encryption, or CSE for short. So those are the three different layers we're going to be talking about. So Atlassian's encryption platform, Cryptor, I mentioned that. It provides a few benefits to us. Centralized key management. We're going to talk about a lot of keys, and you're going to see some numbers here shortly. We manage over 5,000 encryption keys using Cryptor, and that's accessed across 23,000 compute instances inside of our network. The decks we were talking about earlier, there's going to be encryption decks and decryption decks. Encryption decks are ones that are actively encrypting customer data. Decryption decks are going to be decrypting that customer data. And we have 550 million of those in the decryption decks. So how do keys get created? How do they get managed? Here I have a representative service. Let's just call it service A for all intents and purposes. It's using Cryptor. Cryptor is two parts. It's a client-side library, and it's also an open service broker. It manages these keys, the permissions on the keys, and the grants that our systems need to be able to access these keys. Service A has 3 keys. Which specific region, doesn't matter. There's 3 different regional keys. That allows any one of those keys to be able to decrypt and encrypt that data. Service B comes along. What do we do inside of Cryptor? We create 3 keys so that we have this region availability to us, so that if any one KMS region where these keys are accessed, is available, we can encrypt and decrypt that data. We also create a key policy. We also create grants for the encryptors and decryptors that service specified. And we create those and inventory them for the service client. What else do? We ingest that into a client cache. So I talked earlier about how we have so many of these decryption and encryption keys. Those are all cached and encrypted separately inside of S3 for that particular service, so they can be ingested and brought to our SDK to be used locally on that compute instance to be able to encrypt and decrypt data. And that cache is synchronized across all of those instances we talked about earlier. So to bring some other large numbers to this equation, every single day, our cryptor instances are encrypting 25 billion requests, or pieces of data. To translate that to API requests to KMS, that's 256,000 generate data key requests, where we're generating data keys inside of KMS and encrypting them with those master keys. That cache that I talked about on those instances resolve 2 nines for our decryption cache, so they get evicted after a certain amount of time and we only use them when they're needed. And the encryption caches are 5 nines. So whenever data is being encrypted, it's always being encrypted locally on that instance with a cache. That ultimately saves us nearly $76,000 a day in KMS requests because we're resolving all of this locally. Now, we're going to transition to talking about the customer use case of customer managed keys, but I wanted to call out a Gartner report from 22 stating that customers, so organizations, 40% of them will deploy some type of enterprise key management solution by 2026. 2026 is just next year.
Thank you, Trevor. My name is Arun Velagapalli. I'm a senior principal architect with Atlassian. So I'll go walk through, what is our strategy, in approaching some of the customer requirements, right? So you can see a lot of customer requirements that are listed here, some of them, right? So, most of the customers that we go talk to are interested in how do we isolate customer data with encryption, right? So isolation through encryption is pretty important, and also how do we give additional control to the customers by letting them manage the keys, whether it is through the KMS key policy or through the keys themselves or CMK key ARNs themselves, really to kind of maintain their compliance posture, right? So these 3 are the important aspects that we look at. And then if you see, so what we built initially was, we call it as bring your own keys. And if you observe, this is mostly vendor initiated, right? So which means Atlassian key management system that Trevor explained, crypto and its components are going to go and operate directly into the customer's account by asking the customer to create a dedicated AWS account in a specific AWS region, and then create the keys within those regions and set the policy. In this case, customer is basically going through set of operations where they go set up their KMS key policy in the specific region, and then Atlassian basically goes and creates the keys, as you see, in those regions, which means we are basically creating the key ARNs, and then we do the inventory as the next step, which means we have the, administrative capabilities and also the operating capabilities in this model, where we call it as kind of a co-managed system, right? So if you see the key models that we operate at the moment, so, vendor managed is basically, shared encryption model, where for multiple customers, we use shared set of keys, right? So in this case, customer trusts us to use the right encryption models. And the next one is bring your own key, where customer allows us to use their key resource, but they bring the key material, right? So, and then the third one is co-managed, where customer owns the key model, key resource, in this case, KMS, but we are co-managing the policy and also co-managing the keys, meaning Atlassian can go create the keys and also operate on them. The last one is customer managed keys, where customer just gives us the operational capabilities, customer creates the keys, customer also sets up the policies, customer is fully responsible for the key lifecycle management, right? So there's a significant difference between the BYOK model and the CMK model that I would like to highlight. All right, so from the transition, right? So we talked about the initial version was BYOK, and then we transitioned to CMK. The most of these transitions that I can highlight is the permissions model, right? So the key management permissions are now moved from administrative capabilities to operational capabilities, right? So Atlassian doesn't need administrative capabilities anymore. We simply require ability to operate, encrypt, decrypt, generate data key, and also get the key status, right? So these kind of high-level operational privileges are required, and no key creation or deletion anymore, right? Previously, we used to support single root of trust, which is just KMS key, the AWS KMS as the root of trust, but we are looking into multiple options for root of trust, for example, Cloud HSM, external key store, and things like that. And also, the big difference is also in the previous model, since we have these service roles reaching out to the customer AWS accounts, there used to be like dynamic number of AWS KMS keys that we required. In other words, service A creates a new key, and service B comes in and creates a new key. So there is a dynamic set of KMS keys that were being created in the BYOK model or in our version 1 model, which is now basically transitioned to static set of keys. Customer now requires only 2 KMS keys in region A, region B, if it is 2 dual region realm. If it is a single region realm, customer only need to create 1 KMS key. So instead of dynamic, we move to static key set. Right. So some of the key origins that we are looking to support is AWS KMS. We already support that. That is our primary root of trust that we already support. The next one in the order is importing the actual key material. Operationally, it won't be significantly different, but we detect that it is a imported key material and external key origin, right? The third group is Cloud HSM or external key stores. So we group them as separate because it could be outside KMS. If a customer is using some other root of trust, they would like to operate on the same root of trust and not come to AWS for whatever reasons. We use AWS KMS and XKS as a bridge to basically use the same KMS origin, right? So, but you see this. So there are 2 different parameters, right? So for better performance and availability, we suggest customers to come on board using AWS KMS as the root of trust, less overhead for both parties, customer and us. But if customer is really interested in having additional control and greater ownership, for example, customers might choose to own the actual physical hardware or HSMs or the root of trust themselves within their own data centers, then customers can choose to use XKS as the bridge. Right. Yeah. So customer managed keys provide customer least privilege model that I described with very less vendor specific complexity. In other words, customer doesn't have to know or learn how Atlassian manages the keys, the crypto and the complexity around crypto. None of this is required by the customer to understand. These are some of the UX snippets that you can see in the customer-initiated model or the CMK model, where customer basically creates 2 CMK keys, and they set up the KMS key policy. And you can see in the UI, customer creates the keys, and then there's only static set of keys. And we also added additional controls that customer can apply. One is network security control through ability to restrict through VPC endpoints, right? So customer can apply KMS key policy restrictions, only allowing Atlassian network to reach into their KMS, right? So basically, they can only allow these VPC endpoints but not others, right? So that would restrict only Atlassian to call into these KMS resources. All right, so this is the slide that describes the difference between the BYOK and the CMK models that we developed. For example, in this case, in 3 organizations, they are creating their keys themselves. Atlassian is not going in and creating any keys. In whatever region that customer requires, they create the keys. They create the policy, the KMS key policy, and then further we reach out to these KMS key ARNs to figure out, do we have the right policy? Can we operate on these keys? Do a couple of dry runs before we provision the products. And once we determine that, okay, the KMS key policy is configured correctly, and then we can perform encryption, decryption operations and baseline dry runs, then we consider that configuration is correct, and then we provision the products. All right. Some of the lessons learned, right? So customers are more interested in understanding the lifecycle management of the keys. how often they want to rotate the keys is up to the customer. For example, AWS solved the problem of rotation period between 90 days and up to 70 years. So you can do a key rotation on demand or maybe on a scheduled period. So this is a good thing for Atlassian because now we can ask the customer to configure whatever rotation schedule that they would like to configure, and we simply act like a black box. We don't necessarily do anything special. Customer lifecycle management in terms of rotation is completely owned by the customer. There's no activity that we need to perform. All right. So next one is key policy template. So this is an interesting problem that we are working on right now. So imagine various different classes of customers who are willing to operate in various different models. For example, vendor managed, BYOK, and CMK. These operate at different permission levels. So, for example, customer might come on board using BYOK, where customer is allowing us to operate on their keys and also create new keys. But then they might want to transition to a new model. They might want to transition to the next model. So which means there is a change in the KMS key policy, and then there is a change in the set of permissions that customer needs to change, right? So which means we, as a vendor, we need to figure out, okay, is this customer using the right version of the policy that they need to apply? So we are working with AWS in this area to figure out, what's the best model to apply these templates so that, we can figure out, is the customer using the right KMS key policy? That way there is less back and forth between, is the KMS key policy right? Are our dry runs sufficient to meet the KMS key policy requirements? So the other area that's interesting is revocation detection, right? So when a customer revokes keys, the intent can be a number of things. So customer might want to react to an incident, or customer might want to simply test, is their revocation working? Or customer might be going through several internal activities to test revocation or maybe move to a next key model, right? So there are several different permutations. All these intentions from the customer around revocation are going to be hard for a vendor to figure out, is this the right intent, right? So we are trying to work with various different resources, for example, RDS and S3 and various other providers, data store providers, to figure out, what's the best way to detect revocation. When a customer revokes the keys, what are several events that we need to capture, and how do we consistently provide the workflows that need to be triggered post-revocation. For example, Trevor mentioned data keys. Trevor also mentioned some of the data stores that we use to store the data. So the moment customer revokes, we go through a cycle of workflow activities where we revoke access to, to the resources, to the databases, and to the data stores. Also flush away all the data keys, right? So we want to make sure that all the data keys are basically purged. Right, so figuring out the consistent patterns on what is the right event to monitor is also some of the things, some of the interesting areas that we are looking into working with AWS at the moment. All right, these are some of the highlights that we wanted to kind of share, and we have more details we can share with the QR code. Unfortunately, the slide doesn't show you the QR code. We'll be standing here. If you would like to talk about customer managed keys and our journey, happy to share. Thank you.